Hello Legacy Savers! This is the last video to go through the Semester 2 study guide. What you're going to want to have on you is that study guide that you've been working on. This is for exponential and logarithmic functions, so double check to make sure you're on that particular page. In this unit, we focused on exponential growth and decay and logarithms. We graphed exponential equations, we solved exponential and logarithmic. So, very first thing you're going to want to be able to do first, I'm going to get my pen here working. I'm going to write in exponential form. So remember, that was converting. So I'm going to go 4 cubed equals 64. So it starts at the 4, goes to the 3, and then finishes with the 64. Makes an E for exponential. So if I want to go to logarithmic form, it's going to be log with a base of the same base, so 16. Inside the log is going to be 1/4, aka this answer over here, and then equals -1/2. It makes a G, so if you stay here, go over, G. Okay? So you remember how to do that. To evaluate using your calculator, so if I give you log base 4 of 7, some of you might have the really cool cheat calculator that allows you to get a value. So that would be log base 4 of 7. You're going to get an answer of 1.4037. Or if you are using a scientific, what you're going to need to use is log of 7 divided by log of 4. And you will get the same exact value as I do. That's the change of base formula. So depending on what calculator you're using, depends on what you need to use. Expanding and condensing. So expanding, remember, multiplication became addition. Subtraction or division became subtraction. And then powers go out in front. So this one, I see a whole bunch of people out in the front. So I do have to expand this. So it's going to be log base 8 of 3 plus log base 8 of x squared plus log base 8 of y cubed. Okay, so I just made all this multiplication into addition. Then another thing, I take these powers and plop them down there. So I'm going to get log base 8 of 3 plus 2 log base 8 of x plus 3 log base 8 of y. Okay, now condensing, we go backwards. So we got to take care of the numbers in the front, make them powers, and we got to take care of subtraction and addition to make them division and multiplication. So take this 2, make that a power on the x, take the 3, make that a power on the n. So I'm going to get log base 4 of x squared and minus log base 4 of n cubed. Now I know subtraction will turn into division, so I'll make this log base 4 of x squared over n cubed to condense it. Okay, then we did some story problems. I will give you this formula. So for graduation, you invest $1,500 in an account that pays 6.4% interest, compounded quarterly. I need to write the model and get myself for 4 years. So I'm going to go A equals, my P is 1,500. That's my principal, the amount you're starting at. I'm going to go 1 plus my rate, which is 6.4%. I got to change that into a decimal. So that'd be 0.064. And it's compounded quarterly. That's what n is for. You're compounding. How many compounds are you doing a year? Well, quarterly would be 4 times. So it's going to be 4 times t, 4 years. Okay, what I'm going to do, I'm going to type that straight into Mr. Calculator. 0.64 divided by 4 to the power of 16. Now I'm going to get an answer of $1,933.71. If you do it a little off, if you do the inside here, round to about 3 decimal places, take it to the power, multiply by 1,500, you probably will be about $30 to $40 cheaper than I am. It all depends on your rounding error. 7 and 9, we got to use the growth decay equation. So that's the equations that look like this, or the one that looks like this. Okay, so the population of People's Republic of China was 1.273 billion people in 1991. Population grows at 1.5% rate each year. I want to know what's the population in 2009. So it's growing, so I got to use the growth formula. I don't know what's the population after time, so that's what I'm trying to find. A is my initial amount, so 1.273. 1 plus my rate, so I'm going to do 0.015. And my time is going to be 18 years, 2009 to 1991. Okay, I'm going to type myself into the calculator here so I can get an answer. And I'm going to get 1.66 billion people. Why do I put billion? Because ultimately you get 1.66. Well, it was billion to start with, so I gotta make sure I keep that, because otherwise I'll put 1.66 people. That doesn't make sense when I had 1.273 billion people to start with, right? This one, I'm going to buy a new silver Escalade for $63,000. I'm going to be rolling. It depreciates at a rate of 23% per year. Not very good, but you know what? It's fine. After 6 years, I want to know how much my Escalade is going to be worth. So it is depreciating, so that tells me I have to use this problem, that one. They want me to find the value after years, so that means I don't know why, but I do know I bought my Escalade for $63,000. It's going to be 1 minus 0.23, and they told me the time is 6 years. So I'm going to plug it into my calculator here, make sure I don't miss a 0. It's going to be the power of 6. So my silver Escalade will be worth $13,130 and about 61 cents after those 6 years. Definitely not a car to purchase. Now I have to have, they want me to find when, so that means I don't know time for $30,000. So I'm going to plug in my 30,000 here. Equals 63,000. 1 minus 0.23 to the t power. Well, 1 minus 0.23, that is 0.77. Then write that back out here. Very first thing I'm going to do is divide by 63,000 here. So, because I want to get that 0.77 to the power alone. I'm going to get a value of 0.4762 is equal to 0.77t. Now I'm stuck in exponential form, so I do need to convert to log. So log of 0.77 of 0.4762 is equal to t. Using my handy dandy calculator here, I get a value for t of 2.84 years. Definitely not a good car for me to purchase, right? Definitely should rethink that one. I'm going to solve here, do some solving. So e to the 2x plus 6 equals 11. This is an exponential equation. So when you're solving exponential, you want so that you get the base alone, convert to log, and then it should solve. So I'm going to first subtract 6 So I'm going to get 5. Now it's in E, so I'm going to convert to log. I'm going to get ln instead. So it's going to be natural log of 5 equals 2x. So I'm going to figure out what ln of 5 is on Mr. Calculator. I get a value of 1.6094. That's equal to 2x. So if I divide, I will get an answer of 0.8047, roughly. That's a 7. Silly fingers. Okay. 7 to the 2x minus 9 equals 10. This is another exponential. So I got 7 to the 2x equals 19. All I did is just add the 9 over. So now if I convert this, it's going to be log base 7 of 19 is equal to 2x. I'm going to find out what log base 7 of 19 is. I'm going to get 1.5131 equals 2x. Divide by 2 to get my final answer. So I know x will be equal to 0.7566, roughly. Now remember, exponentials, you don't need to worry about what you're plugging in. You only need to worry, just need to solve. Logarithmic, however, you did need to worry. So I'm going to first solve, add 3 over, so I'm going to get 7 log base 5 of x is equal to 18. Okay, now I'm going to divide by 7. So we get log base 5 of x is equal to 18 divided by 7. I get a number of 2.5714. Now, looks like I'm going to have to do some conversion, right? So I'm going to get 5 to the power of 2.5714 is equal to x. So my answer, it's going to be a disgusting decimal, but nevertheless it'll be an answer. It's going to be 62.7092. Now, with logs, you did have to check. Can't have negatives inside of logs. So if I plug that in, it's all fine. You can also make sure you get the right answer by plugging it in. You should get something very, very close to 15 once you do that. And D, so I'm going to first add 4. So I'm going to get negative 2 ln of 2x is equal to negative 10. Divide by negative 2 first. Notice I'm just getting the log alone. Now I can convert, but now it's an ln, so that means I need to change to exponential. I'm going to get a base of e to the 5th is equal to 2x. So e, let me check that. E, where's my e button? There it is. E to the 5th is 148.4132. That's equal to 2x, so if I divide by 2, whoops. I'm going to get a value of 74.2066. And the final problem, graphing exponentials. So, first thing, you need to find your parent, which in this case is y equals 2 to the x power, right? This guy right there is my parent. So, I'm going to make my table. You can always use the same x values, negative 1, 0, 1, and 2. Plug into your parent, so 2 to the negative 1 is 1/2, 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4. Now I got to take care of my moves. So this is a stretch, so that means I'm going to multiply by negative 2 to everybody. This is a left move, right? X plus 3. So I'm going to subtract 3 from everybody. And I'm going to add 3 to the y's because this is going up. So let's find our new table here. So negative 4, negative 3, negative 2, and negative 1. 1/2 times negative 2 is negative 1 plus 3. That's 2. Negative 2, 1. -1, and -5. So let's graph that here. -4, 2, -3, 1, -2, -1, and -1, -5. So it looks like this graph's going to do something like that. Okay, let's see what else do we have to answer. Asymptote. Looks like my asymptote's right here. Your asymptote should always be located at how much you went up and down. Okay, so it would be at y = 3, because normally it's at 0, y = 0. So if I move up, I'm going to move up my asymptote as well. Domain, I'm going to get come on, computer. -infinity to infinity, because I get all the positive x's and negative x's. But my range, I am from -infinity to 3. But notice, guys, I'm not going to include 3 because I can't touch that asymptote because it will not, that's what y values my graph will not contain. And that is the end of the review packet. So if you need to go to any of the other videos to look through any of the other units, feel free. But this is the final. See you later, Savers.